Hello, and welcome back to Lesson 11D, Errors and Links of Quantitative Reasoning online. You should have gone back and looked over the interactive tutorial. And let's go and do the questions, see what they have to say. I bet they're going to look a lot like these guys. Alrighty. Okay, so review the summary of the article, What Drives a 10-Year Cycle of Snowshoe Hares? Complete part A and B. Alright, let's read the article. So in 1831 in Ontario, Canada, the manager of the Hudson Bay Company Post wrote to the head office explaining that a local tribe of Indians were starving. The reason they were starving is because of how scarce rabbits were in that location. They were also able to trap for furs as they needed to spend most of the time available fishing. These extreme shortages of rabbits happened every 10 years. There are Canadian historical documents from the 18th and 19th century, that's 17 and 1800s by the way, that make reference to this 10-year cycle of rabbit shortage. As it turns out, the rabbits were actually snowshoe hares, and more is now known about the cycles within the boreal forest. So which of the following is the best description of the way the snowshoe hare population changes over time? Population increases faster and faster over time? Well, that's not what cycle means. Up and down like a roller coaster, that's a cycle. Decrease rapidly, then decreases slower and slower, finally leveling off. Okay, and that's the logistic curve. Population rises rapidly and slows down, finally leveling off. Oh, that's logistic. The other one was the opposite logistic. Only one that fits the definition of the verbiage is the cycles up and down like a roller coaster. The pattern matches which type of growth? Well, it's not exponential, it's not logistic, it's not linear, it has to be none of the above. Yes. Okay. Assume that z is jointly proportional to x and y, and that when z is 9, x is 10 and 100 and 1,000. Or when x is 10 and 1,000, z is 9. What's the formula for z in terms of x and y? Well, when z is 9, some proportionality constant, x is 10, y is 1,000. So that's k times 10,000. So 9 over 10,000 equals k. And from a previous lesson is 0.0, count to zeros, 1, 2, 3, 4. Tenths, 100, 1,000, 10,000ths is 0.001. So 9 times 0.0001 is 0.0009, which is k. Okay. Given the value of k determined in part A, what is the value of z when x is 20 and y is 500? Okay. So z 0.0009 times 20 times 500, 0.0009 times 10,000, which is 9. Let's put this guy a little bit so I can read it better. Okay, if z is joining proportion to x and y with a positive constant proportionality, will z increase or decrease if x increases and y increases? So again, z equals k x y. What would z do if x goes up and y goes up? Z would have to go up too. Same question, but what would happen? I can't read that. There you go. What would happen with a positive constant proportionality? Would z increase or decrease if x decreases and y decreases? All right. So z is kxy. What would z do if x goes down and y goes down? Z would have to go down. And last but not least, with the positive constant proportionality, would z increase or decrease if x increases and y increases? So here's our constant proportionality. What would z do if x goes up and y goes down? Question mark. Depends. Does x go up a lot and y goes down little, or vice versa? All right. So here we go. Hit save. There we go. Question's done. So now go back and on your own read the questions, get the points for them, and with that you'll be ready then to move on to Stephanie's lesson on the workbook. Complete the work there, make copies, upload them, and then work on 11D practice assignment. And with that, I shall see you later for lesson 11E. Yes.